Welcome back, everybody. Welcome back to the channel. So today we're going to continue parsing statements. So I'm going to go back to our parse statement function. And today we're going to be talking about how to process or how to parse if statements. So as usual, the first thing you're going to need to do is create your is statement or your is function. And that basically just checks to see if the current token is equal to if. And once you do that, and I know I've mentioned it a couple times, but always remember to update your keyword function or the is keyword function just to make sure that you have all of these various keywords for all of our various statements as we're kind of going through the series. And yeah, so once you check that, then basically you want to check to see if there are any access types processed. Just like we did with return statements, you don't want to have any access types after or like before an if statement. That doesn't really make any sense. So once we verified that, we basically say we want to parse an if statement and we return true. So if we go into here, we can check to see. So we have this branch and we want to create a AST if statement branch. And now here's how we get into processing else and if statements. Pretty sure some of you guys are curious about how programming languages do that. Typically, like let's look at the easy part first. So first we have the basic part. So if I go here, first we have the basic part where we have the simple if statement. We say if some, expression, then we want to do something. So in this case, let's say, 5 is less than 10. And so in this example, we have our left function, or the function that basically processes the left parentheses. And then we have our expression that we need to process. This is considered to be called the condition expression. And then we have our right parentheses. After that, we parse a block. And what that'll allow us to do is, just like other programming languages, if we don't want to have the brackets or the curly braces, then we can just say, return some value or something. So that's really nice. Also, we need to create a couple variables here. So we need to create a temp AST, and we also need to create a Boolean called is/else. And we'll see what that is in a little bit. So in order to process else if statements, what we need to do, and if you technically think about it, right, like here's the format. So we're going to have else if, and then let's say true, for like something easy to process. Then we have else. So it doesn't matter what the hell you're processing inside of these expressions, this will always be the format. So if you have like, if true, else if true, else this. So with that in mind, basically, if you look here, we have if, and every single other statement after that has the word else in front of it. So that is why I have if the next token is equal to else. If the next token is not equal to else, then I don't even entertain processing else if statements or even else statements because it doesn't make any sense. So if the next token is equal to else, then I check to see if the next token after that is equal to if. And if so, then that means we have an else if statement. Otherwise, we have an else statement. So if we look here, the next token is equal to if, then that means we have an else if statement. So we create a branch of else if. Now this is very important. This is why we need the temp AST. You want to pass in the branch. Do not pass in AST. If you pass in AST, that's going to be basically at a different level. It's basically going to put it on the same level as this AST if statement. No, you want this else if statement to be inside of this branch right here, representing the whole if statement. That way we can process it later. So once we do that, once we create our else if statement branch, then we basically advance and consume both tokens. Now we don't need either of these tokens, so you guys can probably just say advance twice. So just advance and advance without really having to add the tokens. And then we basically expect the left and right parentheses. And we expect our condition expression in between both of them. So that's how we process an else if statement. So, we have our else if, we process, both left and right parentheses and whatever the expression is. After that, we finally have our else statement. So if we check to see if the next token is equal to else, and if the next token after else is not equal to if, well, it's only safe to assume that it's an else statement. So we basically create another branch called AST else statement. We advance, we consume the token. Again, you don't really need to do this. I don't know why I keep consuming all these tokens, but whatever, it's fine. And then finally, we have our is else equal to true. And the reason why we need to have that is basically after this, so like after we process our else statement, after we process our if statement, depending on which one we process, we call the same code down here to parse a block on whatever the temp AST that we just created is. So like, since we're sharing code, we want to kind of limit the amount of code or the amount of duplicate code that we're writing. So we want to basically just call parse block on either a else if statement or an else statement. And if it's not equal to else, basically that means that we can continue processing else if statements. Because whenever you have a if else block or an if else statement, you can't have anything after an else statement, because else basically means like if everything fails, if all else fails, we want to do this as the final like drawback or the last resort. So we just want to make sure that if we do not have an else statement, then we go back up to condition expression, which then continues to check to see, what is next. So like even in the case where we process like an else if, it's totally legal that we don't have an else statement here. We're not required to have else statements. So if we process this if, we process this else if, what will happen is basically we'll see that it's an else if statement, we'll contain or process all this code, we'll parse a block, we'll go back up to the top, and we'll just ignore it because there's nothing after it. So totally fine. And yeah, so that's how I process if statements. So I'm going to go back to my compiler here, and let's look for, where did I put that code? I put it in compile return statements. So I'm going to take this code out and go to compile if statements. All right, so I'm going to put this here and let's see how this actually looks. All right, so I'm going to scroll all the way up to the top and we can look at what this if statement is or how it looks. So if we look here, we have our if statement, we have all of our various tokens. Like I said, you don't need to add these if you don't want to. So we have our condition expression. So let's say, let's actually make this better. So let's say is low, and let's say is high or something. I don't know, just something to distinguish both expressions. So if I go back up to the top, you can see here that we have our if statements. We have our primary expression of a dot notation call expression of is low. And this first expression, or this first condition expression, represents the condition expression for this if statement. If we scroll down, we can see we have the block, and this block pertains to this if statement as well. And then we have our else if statement. So now we are here where we're checking to see otherwise if high, or if is high. Then we have our else if, you can see we have those two tokens. Then we have our AST expression of a dot notation call expression and is high. So that looks to be working properly. And then we of course have again another empty block. After that, we have our else statement, and that just contains a block. So else statements are pretty straightforward. And yeah, so that's pretty much it for if statements. As usual, if you guys have any questions, definitely write them in the comment section below. And of course, if you guys would love to help support the channel, definitely head over to my GitHub repository at androidevcd/sharp. And when you guys get there, definitely watch, star, and fork this repository. That's going to give this language a lot more visibility and let other developers know this language exists. Also, if you're interested in seeing what I do on a daily basis with the language in terms of updates, bug fixes, you can check out the remastered branch. And this is pretty much the main branch that I work off of on a daily basis. And I also have some pretty wordy commits, so if any of you guys are kind of interested in seeing what I've been up to, you can kind of just look here and you can really just get a gist of what I've been doing over the past couple days and weeks without really having to look too much into the code. Also, if you guys are curious about seeing maybe some of the things that I've done to the past in the language, or maybe stuff that I'm looking to add into the future, you can head over to the docs folder, and that's going to contain two main files. So you can either have the change list file, and that's going to be pretty much everything that I've added to the language in the past in terms of updates, bug fixes, so on and so forth. And then you also have the roadmap file, which pretty much contains everything not only have I done in the past, but also things that I'm looking to add in the future. So definitely recommend checking out this file. It gives you a lot of insight into the language. And yeah, so that's going to be it for today, guys. As usual, if you guys are new to the channel, definitely consider subscribing. And until next time, I'll see you guys later.